Just hit a button, Morty. Give me a beat.
Oh man, okay, alright,
What up, Berry Bears? This is your favorite coach that does the most, Coach Givens. What? And today, I'm going to teach you about scientific notation. So first, what is scientific notation? Great question. Scientific notation is basically a special way to write numbers. It's an abbreviated version of super large or super small numbers. It's used with a base 10 format, and it usually has an exponent. Okay, now that that's over with, let's take a simple number like 700. This is considered to be standard form because normally you write the number 700, 700, right? That's standard. But in scientific notation, it looks a little different like this. 7 times 10 to the second power. All right, so first we have the leading number, which is called the coefficient. The coefficient must always be between 1 and 10. So in this instance, it's 7, and that falls between 1 and 10. Then remember I said that scientific notation has a base 10 format. So basically what we're doing is multiplying the coefficient times 10 to the second power. In math class, we normally say 10 squared. But for scientific notation, we change that just a little bit and call the exponent like this, 10 to the power of 2. All right, I know it seems confusing now, but just hang in there with me. All right, so here it is again, from 7 times 10 to the power of 2. The first thing we need to do in order to understand scientific notation is to understand how this works mathematically. In class, we've taken 10 to the second power, and basically that means 7 times 10 times 10, right? And of course, you know that 10 times 10 is 100. So this is basically like doing 7 times 100, which is 700. So again, 700 and 7 times 10 to the second power have the same value. They're just written in different ways. All right, well, now that that's the mathematical part is done, let's get some practice. And yes, we're still talking scientific notation. Today, we're going to focus on super big numbers. I mean, usually scientific notation can deal with very large numbers or very small numbers, but we're going to focus on super big numbers today. Like this one, 4,900,000,000. It's a lot of zeros. This is in standard form. This is how you write 4,900,000,000. So in order to change it to scientific notation, first, you need to drop a decimal between the first and the second digit. In this instance, 4 and 9 are the first and the second digit, so you're going to drop a decimal right in between those two numbers. Step 2 is to count the number of places to the right of the decimal. So let's start at the end here. I see 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 places to the right of the decimal. Step 3, you just rewrite the number in scientific notation. So you're going to need the coefficient, which is 4.9. Remember, it has to be between 1 and 10, and 4.9 falls between 1 and 10, so we're good there. Then the base, so times 10, so 4.9 times 10, and then the exponent, which is the number of places to the right of the decimal. In this instance, it's 9. So the way you write 4,009,000,000 in scientific notation is 4.9 times 10 to the 9th power. All right, so here's the big idea. All we're trying to do really is to take a really large number and just make it much smaller. And today, again, we're going to focus on large numbers. All right, here's an example. The population of the world is around 7 billion. So in standard form, 7 billion is written 7, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Now let's try to break this bad boy down into scientific notation. The first step is to identify the coefficient. And then we're going to drop a decimal between the first digit and the second digit. In this instance, it is 7 and 0. So if we drop a decimal there, it becomes 7.000000000. Well, we don't have to write all of that for the coefficient. We just write the number between 1 and 10, which is 7. Cool. Then we got the base times 10. That's easy. Now we count the number of places to the right of the decimal. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our exponent is 9. And the way you read it is 7 times 10 to the 9th power. Or 7 times 10 to the power of 9. All right, here's another example. The distance from the Earth to the Sun is 93 million miles. It's a long way. In standard form, you write it like this. 93, 0, 0, 0, 0, 0, 0, 0. Scientific notation, you drop a decimal in between the first and second digit. So what? Yeah, 9.3. And then base 10, so times 10 to the... Now we have to count the number of decimal places to the right. And it's 7. Yeah, there are 7 places to the right of the decimal. So scientific notation for 93 million is 9.3 times 10 to the 7th power. Cool. All right, one more example. The distance from the Earth to the Moon is 240,000 miles. All right, this one might not be as big as the other ones, but it's still a pretty large number. In standard form, you write it 240,000, but you knew that already. So let's take a second and break it down into scientific notation. Scientific notation. First step, drop the decimal. So we put it between 2 and 4. 2.4. Don't forget your base 10, so times 10. And then count the number of decimal places to the right of the decimal. How many places did you count? Hopefully 5. So 240,000 in scientific notation is 2.4 times 10 to the 5th power. All right, I think I'm done. Why don't you try on your own? Here's an example. Write 1,260,000 in scientific notation. Don't worry, I'll wait. Okay, I'm tired of waiting. Hopefully you got 1.26 times 10 to the 6th power. All right, here's another example. Try to extend your learning just a little bit. Let's go in the other direction. Write 3.99 times 10 to the 5th power in standard form. Don't worry, I'll wait. Alright, that was a little tricky, right? Nah, not really. So, you should have written 399,000. If you got them right, congratulations, you're done learning for today. If not, go back and check over some areas that you might be confused about. If you need more help, definitely shoot me an email, send me a message on Remind, or leave a comment underneath the video on Google Classroom. Feel free to Google it, YouTube it for extra practice, and I'll talk to you later. Holla!